Yeah, hi guys, Bruce on from Parity Blockchain. I'm the head of adoption. And I'm going to talk to you guys a little bit about the bring your own coin blockchain. And I hope after this presentation, it'll give you guys perhaps a little bit of a different perspective on what L1 chains are currently and where L1 chains could go in the future. So I want to first begin by talking about how the current L1 experience is kind of like playing in an amusement park. So if you go to an amusement park, what is the first question that they ask you? The first question that they're going to ask you is, hey, welcome to Disneyland. Would you like to buy some Disney dollars? And the reason why they ask you this question is because in order for you to transact in Disneyland, you have to pay for it using the Disney dollars. And it's kind of similar in the L1 ecosystem, isn't it? When you go into a L1 system like Ethereum, BNB, Matic, whatever, and whether you want to transact in there or whether you're building in there, you have to own that particular token. You can't use anybody else's. So every park is really in competition with each other. Every L1 right now is in competition with each other. And it's really like a zero-sum game. Everybody's saying, hey, I'm the fastest. I'm the cheapest. I'm the easiest to build on. Come build on my chain because I'm going to be the winners at the end. Oh, by the way, if you're going to play my chain, you have to pay for it using my token. And that very much is a definition of what a zero-sum game is. And in our opinion, that's not what an infrastructure should be, right? If you're using the internet as an example, you don't go in and say, hey, I want to access the web. I'm going to pay in Ethereum. Then the Ethereum people will say, hey, please pay for it using Ethereum. But you can only browse the website that is built using Ethereum. That's not what an internet is, right? Internet is an infrastructure. It is a free access where everybody has access to everything. But unfortunately right now, the L1 ecosystem is kind of like just a simple ecosystem and not a real infrastructure. It's a challenge. But what if there was a system, an ecosystem where you can actually pay using the token that you wanted to pay with? What if you could go into the BNB ecosystem and pay for it using Ethereum? What if you could go into the Polygon system and then pay for it using BNB tokens? Wouldn't that be wonderful? And this is our vision. This is basically Parity Blockchain's vision and our belief. Our belief really is that for an infrastructure to continue to succeed, you have to collaborate rather than compete. And so what we've devised is what you really call a bring your own coin blockchain. You can pay for the system using any different types of tokens that you wish. Now, Parity Blockchain also has other value propositions. We are primarily a multi-party computation technology. And I'll go into a little bit more about what that is. But we actually hold the largest multi-party computation network that is currently securing our Oracle private keys. And we also collateralize and insure using our MPC tokens. And this is the reason why you don't need the MPC token in order for you to transact in our system. You can actually use other coins. So why did we choose this type of a model? What is the reason? One of our founders, Kurt Nelson, he holds a PhD in economics and also in game theory. And we were looking at the actual tokenomics or the economic models of other chains. And we wanted to do something that was different. We wanted to actually go into a system and build something that mirrored sound economic models that is used around traditional finance. So the first thing that I want to point out is the basic decoupling of a store of value versus a means of payment. What does that mean? What does that mean right now when you say, I want to separate between what a store of value is versus a means of payment? Now, I'll give you a really simple example of this. Let's say gold coins. I don't know if any of you guys are gamers, right? If you go into a video game, you pay using copper coins or silver coins or gold coins, right? And that is a form of payment. But let's take that example in the real world, right? You want to buy a cup of coffee. Right now, and let's say that you're going to buy a cup of coffee using a gold coin. Gold coin is currently a store of value. But you want to buy it using it as a means of payment. So one gold coin costs a cup of coffee. But because it's also a store of value, the actual worth of that gold coin increases or it'll decrease and it'll fluctuate. So when you associate a store of value with a means of payment, you get into this kind of a really strange situation where one day you're paying $10 for a cup of coffee, and then the next day you're paying $1, and the day after that you're paying maybe $50 for a cup of coffee. Because now you have associated the store of value and tied it to the means of payment. And I'll go over a little bit more in detail about this issue that's currently in the blockchain industry. But we also wanted to, as I said, wanted to collaborate. And so this is the reason why we actually have the payment structure in our chain using other coins. But we're not associating that with the actual token itself. We're actually converting that to US dollars. And so transactions on our chain, even if Ethereum's price skyrockets to 10,000, our transaction still will be 1 cent. It doesn't really matter what the store or value price for that token is, because our means of payment is computed in a different way. And this is extremely important when I go over the value proposition this has when you're running a business. So, a little bit more about Partisia blockchain. So as I mentioned, there's 3 different value propositions. We talked a lot about interoperability. We talked about the fact that our chain's cost is still paid using different tokens, and that the cost is stable, it doesn't fluctuate. But our real value and our real technology is based on privacy. We actually have a generically privacy-preserving computation called multi-party computation. I don't know if you guys have heard of that. I'm sure almost everyone in this room has heard of zero-knowledge proof. And I'll give you a comparison between what zero-knowledge proof does and what multi-party computation does. And then we also have a very interesting scalability model. And I'll delve a little bit more into that in the next couple of slides. But basically, we actually have 3 different technology values that is being operated by our node operators that is actually doing real-world work. And I'll also go into a little bit of examples of some of the real-world work that we're doing. It's not based on some of the other interesting models where you're creating worth out of thin air. This is actual real work that we're doing. So, let's talk a little bit about our Baker nodes. And because this is an infrastructure conference, I want to talk a little bit more about what our infrastructure really looks like. And ultimately, in the end, what you can do with our token, because we're also talking about restaking and getting rewards when you're running a node. So our Baker nodes. It is our consensus node that does all of our consensus. It does our validations for the blocks. It does all of the validations for all the bridging, and also on zero-knowledge proof. One of the things that you'll find unique about our blockchain is that we have a sub-second true finality. And we also have what's called a eager block creation. It doesn't need to wait for an epoch before the next block is created after the previous block is finalized. The other thing that I'll just point out here, which is unique, is that you'll see multiple shards. We actually have multiple shards from scratch, from day one. We've implemented it and it's running right now. But our sharding is not like any other sharding that you guys are aware of. One thing that I'll mention about sharding is that it is not a blockchain term. Sharding actually comes from database. If you ask any DBA, they'll tell you, oh yeah, I know what sharding really means. It was created in the 1990s. It's been around for a long time. But the blockchain industry has redefined what sharding really is. So what we actually did was we went back to the original definition of what sharding really is, which is basically multiple different independent databases transacting in parallel. In the current blockchain, you have a single blockchain, and every block is being created, even if it's done through parallelly, it's one block that's getting created and getting appended to the end of the chain itself. It's a single blockchain. In our blockchain, we actually have multiple different blockchains running in parallel. We actually have 4. And then when there's congestion, we can scale out. We can add a 5th, 6th, 7th, introducing a horizontally scalable blockchain, going beyond, from a scalability perspective and a performance perspective, than any other blockchain that's out there right now. And then we also talked about MPC, multi-party computation. It is a way for you to compute on private information. So let's say as an example, people in Dubai, between the ages of 45 and 55, who has this kind of a lifestyle, it's a smoker, female, has this type of a cancer, and is taking this therapeutic drug. What is her mortality rate? What is their mortality rate? Right now, researchers are looking to find out what that is, and it's incredibly important for them for their research. But this is private medical information. You can't share this data. But how can you give access to this information to the researchers without leaking your data? Let's give another example. Your phone has GPS information. Do you know if your phone providers are accessing your GPS information or not? Because that information is extremely valuable to them. So how can you give, or how can you allow for your phone companies to compute on your GPS location without exposing the details of your GPS information itself? And that's what multi-party computation does. We're actually working with health industries to compute on health data. We're working with DID organizations to go beyond just a simple yes or no check. And this is all being done by our zero-knowledge nodes. And all of this work is currently being paid for using Ethereum, BNB, Polygon, USDC, and USDT. Real-world work that people are doing on our chain, and the node operators are being rewarded in real value tokens for this kind of work. So I talked a little bit about multi-party computation, the difference between zero-knowledge proof. You guys have heard of zero-knowledge proof before? It is a proof system between 2 parties. You have a prover and a verifier, and the answer is always a yes or no. And it's great at simple situations, but when you need to scale out further, when you have to have multiple people in the equation, if you have to have answers that are more complex than just a simple yes or no, zero-knowledge proof does not scale. So that's where you need multi-party computation. And then we talked a little bit about our Oracle nodes, right? It is our bridge. It is the system that allows for the payment of tokens, the payment of our chain using those various different tokens that we talked about. And we talked a little bit about our large-scale MPC that replaces the Oracle right now, the largest MPC cluster in the world. And the tokens, our MPC tokens themselves, because they're not used for gas, they're actually a store of value, not a means of payment, like we talked about. That MPC token provides collateral and insurance for the actual bridge that goes across. Now imagine, you've heard of multiple bridge hacks in the past. And there's LayerZero right now, outside, they're talking about, messaging systems. Then yes, we provide a messaging system. This is exactly how this works. We have a messaging protocol that that transmits value or information from one chain to another. We are a cross-chain messaging platform. But one of the differences is that we actually are collateralized and ensures the information or the assets that's being bridged so that if there is any kind of a malicious activity, your assets are insured. You will get your money because it is protected and is insured, it's collateralized. And again, this job is being run by our node operators, and they're getting paid real money by providing this valuable real-world service. So let's talk a little bit about what you can get out of having such an infrastructure. We talked about the fact that there is, in LO1s, it's a it's a zero-sum game, right? We talked about the fact that everybody's saying that I'm the winners, come build on my chain, and you gotta pay for my tokens if you build on my chain, et cetera, et cetera. So what are the actual values that you get? So here's advantage number one. I'll give you a really simple example. Let's say that you're a video game developer, you're developing on Binance, you're developing on the BNB chain. And this game is awesome, it's amazing, it's the best game in the world, it beats World of Warcraft, it's amazing. But because you built on BNB, your customer base is restricted to people who own the BNB token. That's your customer base. Ethereum token holders? No, no can do. They cannot play your game. But what if you build on a network that accepts multiple different tokens? You've opened up your customer base to not only BNB token holders, but Matic. Users can pay for it using Ethereum, USDC, USDT. It doesn't matter. People can pay for it using Cardano, WBTC. Imagine people playing your game or interacting with your application using WBTC. Imagine that. Advantage number two, we talked about the fact that Partija blockchain's expertise is in multi-party computation. Privacy data that you can compute on without exposing the private data itself. But we also talked about the fact that we believe in collaboration. So now by allowing other tokens to be payable as gas, we provide multi-party computation as a service. Other applications and other ecosystems can now call us as a service, get those computations and bring it back into their application. I'm an Ethereum diehard. I don't want to build in somewhere else. And I spoke with somebody who talked about that. We were talking about today. It's like, it doesn't matter how expensive the gas payment is. I believe in Ethereum and I'm going to continue to build there. This is the future. Okay, that's okay. You can still call our chain as a service to take advantage of whatever services that you want to take advantage of. Pay for it using E. And then take that value back into the system. Collaboration. And value advantage number two, or advantage number three. We talked about the fact that if you're running a business, if you have a real business, it's very difficult for you to be able to forecast your business model against a store of value asset that continuously fluctuates, and you want to use that as a means of payment. The unique thing about our chain is that it doesn't matter if any of these tokens rise in price. Because ultimately, in the end, the cost is calculated in USD. It will always be 1 cent a transaction, or 10 cents a transaction if you're doing multi-party computations, or whatever the cost is for a transaction. It will always remain the same, whether you have 10 users, or 100 users, or 1,000 users. You can still compute out and forecast your business model. You can't do that with a chain that fluctuates its gas cost. So ultimately, in the end, this is all the services that is provided by running a node. Everything here that we talked about before is all being run through our decentralized node operators. They run our network. We do not run it. They run it. And as a result, and as they run all these different services, not only are you rewarded with MPC tokens, you are also rewarded directly with the gas payment tokens that is being run on our network. You get rewarded in USDC, you get rewarded in USDT, Ethereum, BNB, Polygon, any other tokens that we will onboard in the future. Real world work that is being provided by a network that will reward you in tokens that have real value in the network. We believe that interoperability, we believe that privacy, and we believe that scalability is the key for the blockchain industry. It is to continue to grow. And this is our contribution to it. Thank you.